So 4 or 5 notes. We're doing systems of equations again, but you will notice a significant difference between the systems of equations from the previous unit versus these now. So looking at our example 1 here, the top equation has an x squared in it. Since it has an x squared, we call it quadratic. And if you look at the graph, that U shape, that is the quadratic function. That U shape has a name. Drew?
Parabola.
Yes, good. By far the quickest response today. Parabola is correct. Bottom equation, that has just the x, and we call that linear. Linear as in a line. When we answer the questions for these examples, the question really is, what are the solutions to the systems below? What it's actually asking, where do the graphs cross? And more specifically, cross each other. Looking at this first example here, how many times do they cross? Twice. So the number of solutions, that's 2. The actual solutions to the system is where they cross. We have 2 points here. So we have to state their coordinates. The point on the bottom left here, what are the coordinates? 0, -3. X is 0, y is -3. And the point in the top right? 4, 5. Good. Second graph, how many solutions? Just 1. They only cross 1 time, and what is this point? -2, 5. Good. Last graph, number of solutions. 0. They don't cross at all. They will never cross. So in that case, when it asks for the solutions, we just put none. Hopefully that felt pretty straightforward. When you're given the graphs, this question is very easy to answer. When you're not given the graphs and just given the equations to solve by hand, this process takes a bit more time. Everything we're about to do in here, we have done before in some other unit up to this point. We just haven't put them all together into one problem. First step here. Make sure both equations are y equals, and then everything else is on the right side. You just want y on the left side. Looking at our equations, we have y equals x squared plus 4x plus 2, and y equals -2x minus 3. We have y equals just y on the left side. That's exactly what we wanted. So we can go right into the next step. Set the equations equal to each other. Here's the explanation for this. And what we're doing here is actually a form of substitution. But we have both y on the left side. So first, is y equal to y? Of course, it's equal to itself. So the logic here is if the left side is equal to itself, then the right side must also be equal to itself. So going off of that, we can say that x squared plus 4x plus 2 is equal to negative 2x minus 3. From here, step 3, solve for x. Your options are factor or quadratic formula. So step 3 is what we did on the last test. From here, what do I need to do first? Move the 2x. That's a negative 2x, so I'll plus 2x. And I'm going to put it under the 4x on the left side. That's its like term. X squared plus 6x plus 2 is equal to negative 3. What's my goal here, what I'm doing right now? We want it to have a 0, so we need to move the negative 3 to the left side as well to accomplish that. Plus 3, put it under the 2. X squared plus 6x plus 5 is equal to 0. From here, we can factor or use quadratic formula. Factoring is much faster. I feel like there's less room for errors, so that's what I'm going to use. First off, what do we call this on the left side? Trinomial, good. So we have A, B, and C here, where A is 1. What do I use to factor it? Yep. ACB chart. So we're going to have our two factors set up like that. ACB chart, A is 1, 1 times 5, that's just 5. And it's a positive 5, so we're just adding on the right side to get the B value. And then B is 6. 5 only has one pair of factors, 1 in itself, and luckily when you add 1 and 5, you do get 6. Checking. 1 times 5 is 5, yes. 1 plus 5 is 6, also yes. So our factors are 1 and 5, x plus 1, x plus 5. Now what? We're going to split these up into two equations. X plus 1 equals 0. X plus 5 equals 0. Subtract 1 to both sides. We get x equals negative 1. Subtract the 5. X is negative 5. We are almost done. So our goal obviously is to get an answer. In this case, we'll have two answers. Let's go back up and remind ourselves what these answers look like. What do the answers, the solutions, look like to these problems? What are they? They're points. So right now we have two x values, but we are missing the y values for those points. So step 4, plug each x value into one of the original equations and find y. Are you giving me an answer? One more time? No. Which, no. Okay, no. Sorry, I hadn't heard your whole question yet. Nope, it doesn't matter. Follow-up question? Okay, pause. So, I forgot to label these E1 and E2 earlier. That's a flashback to systems of equations problems, especially systems of 3. But we're going to plug it back into one of these two equations. It's your choice which one to use, but I hope we agree E2 is a much easier equation to use. It has just x, it doesn't have x squared. So I'll be plugging both x values into E2. And we have to do this twice because we have two x values here. So we know x is -1, y we need to figure out. So we're using E2, which is y equals -2x minus 3. That's -2 times -1 minus 3. And if we were to put that into a calculator, we would get -1 is correct. Y is -1. I'll go ahead and write down the first answer over here. Remember, these are points, x, y. X and y in this case are both -1. And I'll have a second point. My other x value is -5. And then we'll figure out what its y value is. Once again, I'll be using E2. This time I'm plugging in -5 for the x value. So 2 times -5 minus 3, which will give us 7 is correct. Again, you could just type that into a calculator if you wish. So our other point is -5, +7. These are both the answers to this problem. Now, if you notice in the directions above, it says to solve the system and check using the Desmos graphing calculator. I'm not sure how much experience you guys individually have with that, but we are going to take a look at that as well, just to show you it's an easy way to check your work. So I'm going to take a moment and do that.